Okay, so here in this video we will discuss about priority encoder. What is priority encoder? Priority encoder is also a combinational circuit. Priority encoder is also a combinational circuit. In this circuit, there are 2 raised to power n number of inputs, and according to these inputs, we will get n number of outputs. Okay, But there is one difference, but there is one difference between a normal encoder and a priority encoder. What is the difference between them? In priority encoder, each input is having one priority. Suppose here I am considering 4 inputs D0, D1, D2 and D3. Okay, suppose in this priority encoder, suppose this one is a priority encoder, and in this priority encoder I am taking 4 inputs D0, D1, D2 and D3. Okay, so according to this input we know that we will get two outputs. I am representing it as A and B. Okay, why there are two inputs, why there are two outputs? Because we know that in any encoder there are 2 raised to power n number of inputs, and accordingly we will get n number of outputs. Okay, so in priority encoder each input is having some priority. The priority of D1 is greater than priority of D0. It means that priority of D1 is greater than priority of D0. Okay, the priority of D2 is greater than D1 and D2, D1 and D0. Okay, and the priority of D3 is greater than D2, D1 and D0. These are some priorities. Okay, it means that if if our input is D0, D1, if our input is D0 and D1, both are 1, so we will consider this D0 input. Okay, it means that suppose D0 equals to 1, D1 equals to 1 and D2 equals to 1. So at that time we will consider this D2 input. Okay, because there is some priority in this priority encoder. Okay, so on the basis of this theory, we can draw various types of priority encoder. Out of them, some are, we can draw 4 to 2 priority encoder. We can draw 4 to 2 priority encoder. Okay, now to analyze 4 cross 2 priority encoder, we need a truth table. The truth table for 4 cross 2 encoder is shown below. The truth table for 4 cross 2 encoder is shown below. Okay, here I am taking some inputs. Such as, here I am taking some inputs such as D0, D1, D2, D0, D1, D2 and D3, and accordingly the outputs are A and B. But to check the validity of the output, we can also take one more output that is represented as V. Okay, now how this truth table works? When all inputs are 0, 0, 0, 0, 0. Okay, so at that time, if the priority of all inputs are 0, so there is no input is possible. So at that time the validity will be 0. Okay, but in second case, when the input is 0 0 0 and 1 at that time. Because d0 is 1, that's why the encoder will provide the zeroth binary form in the output side and it is valid. In next case, when the input is 0 0 1, so it doesn't matter that the d0 is 0 or 1, so we can write it as don't care. Okay, so in this time, because of the highest priority of d1, the output will be 0 1 and it is valid. In the next case, when input is 0 0 0, wait a while. Okay, so in next case, when d2 is 1, so it doesn't matter that d1 and d0 will be 1 or 0. At that time, the binary form of d2 is transmitted towards the is encoded. Okay, so it is also valid. That's why the validity output equation will be 1. In last case, when d3 input is 1, so because of its highest priority, it doesn't matter the what is the value of other inputs. Okay, so at that time, the binary form of 3, that is 1 1, will be transmitted and it is also a valid output. Okay, now on the basis of truth table, on the basis of this truth table, we can generate various equations, such as if I want to generate a equation for a. So what is the equation for a? To find out the equation for a, we will check where is 1 in a's column. This one is 1 and this one is 1. Okay, this is 1 and this is 1. It means that for 1, don't care, the output is 1, the output is 1. Okay, and in second case, what is that in second case, for 1, don't care, for 1 cross, the output will be 1. Okay, don't care means it may be 0 0, it may be 0 1, it may be 1 0, it may be 1 1. Is it clear to all of you? It means that for all these possible inputs, the output A will be 1. For all these inputs, the output A will be 1. Okay. Now here the next combination is A cross cross cross. So if I represent these cross in terms of 0 and 1, so what we can write? We can write it as 0 0 0, then 0 0 1, then 0 1 0, then 0 1 1, then 1 0 0, then 1 0 1, then 1 1 0, and at last 1 1 1 1. It means that for all these input combination, for all these input combination for all these input combination, the value of A will be 1. Okay, so on the basis of this analysis, this analysis, we can say these 4 and 5 6 7 8 9 10 11 12, and for these 8 total, for these 12 combination, the value of A will be 1. Okay, so when I minimize it using K-map, so to minimize it, we need a K-map of 16 cell. Why we need a K-map of 16 cell? Because there are 4 different inputs, D0, D3, D2, D1 and D0. So here I am writing D3 and D2, and here I am writing D1 and D0. Okay, now it is 0 0 0 1 1 0 and 1 1. Here it is 0 0 0 1 1 0 and 1 1. So here we can say for only 0 to 3, the value of A will be 0, and for other inputs, the all outputs for other input combination, the value of A will be 1. Okay, it means that A is 1 for all output combination except the first 4. Okay, so for these 12 combinations, the value of A will be 1. So when we group these inputs, so first grouping that is possible is this one. First grouping that is possible is this one. So what we will get from this grouping? What we will get from this grouping? We will get what we will get from this grouping? 0 0 0 1. This one is 1 0 and this one is 1 1. Okay, so what we will get? We will get D3. What we will get? D3. Okay, now when I group this one, when I group this one, so what I will get? What I will get? What I will get? I will get here 0 0. I will get here D2. Okay, you can see, here what is writing here. Written element is 0 1, here written element is 1 1, and 1 0, and here written element is 1 1. Okay, so when I grouped third and fourth row, so this D3 is common. That's why from the below mentioned grouping that we will get output as D3, and from upper grouping we will get D2. So the equation for A will be, D3 plus D2. Okay, same as A, we can also calculate the equation for, B. How can we calculate the equation for B? To calculate the equation for B, we need truth table, and from this truth table, we can see B equals to 1 for 1 cross. Okay, B equals to 1 for 1 cross. B equal to 1 for 1 cross. Okay, now the next one is for 1 cross cross cross. Okay, next is 1 cross cross cross. Okay, 1 cross 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 is, similar to this one. 1 cross cross is similar to this one. It means that for 8 to 15, all inputs will be 1. Okay, okay, and from 1 cross it means that 1 0 and 1 1. Okay, so what we can see? We can see 2 3 is 1, 2 3 is 1. Okay, so B equals to 1 for, so what we can write? B equals to 1 for, 2 3, then B equals to 1 for 2 3, B equals to 1 for 2 3, and then 8 to 15. Okay, 2 3, then 8 to 15. It means that 2 3, then 8 9 10 11 12 13 14 15. Okay, so to minimize this equation, we need a K-map again. We need a K-map again. So here the input is D3 and D2, and here the input is D1 and D0. This one is 0 0 0 1 1 0 and 1 1. Same is 0 0 0 1 1 0, and this one is 1 1. So 2 3 0 1 2 3, then 4 5 6 7, then 8 9 10 11 12 13 14 15. Okay, so this one is the cell for B. So in this cell, this grouping will be possible. For this group, we will get output equation as D3. We will get output expression as D3. Okay, now from this grouping, we will get output equation as D2 bar. We will get output equation as D2 bar D1. We will get output equation as D2 bar D1. Okay, so this one is the equation for B. This one is the equation for B. Now which one is remaining? Now which one is remaining? Now the remaining one is V. Now the remaining one is V. From this diagram, it is from this truth table, it is clear that from this truth table, it is clear that 1 0 1 0, it means 2. Okay, 1 0, V equals to 1. V equals to 1 for 0 1 1 0 1 1. Okay, so it means that V equals to 0. V equals to 0 for only the combination of zeros. V equals to 0 for only zeroth cell. So what we can write here? We can write it as for 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. For all these 15 inputs, the V equals to 1. So I use K-map, when I use K-map to minimize this equation, to minimize this equation. So what we will get? What we will get? This one is D3, D2, this one is D1, and this one is D0. Okay, 0 0 0 1 1 0 and 1 1. This one is 0 0 0 1 1 0 and 1 1. So except zeroth cell, every cell is filled with 1. Every cell is filled with 1. Every cell is filled with 1. Okay, so how many grouping is possible here? First grouping will be this one. Okay, first grouping will be this one. From this grouping we will get D3. Okay, now the second grouping that is possible here is this one. So from that grouping we will get output as D2. Okay, so now to cover these two elements, we can use the vertical grouping. So from this vertical grouping we will get output as D1. Okay, now to cover this element we will use this vertical grouping. So from this vertical grouping we will get output as D naught. We will get output as D naught. Okay, so these are the following three equations for the 4x2 priority encoder. Okay, thank you so much.